Okay, the last letter. This is the last letter for the thermodynamics chapter. G. G stands for Gibbs free energy. What does it mean? Spontaneity. Oops. Spontaneity means, will this reaction take place, yes or no? Okay, it's a lot like K. We're going to talk about what they mean, how they're related in just a little bit. So there's an equation to solve for G. It's delta H minus T delta S. If you'll remember, H is enthalpy, S is entropy, T stands for temperature. So the Gibbs free energy, or the spontaneity of the reaction, depends on if it's endo or exothermic, and it also depends on if it's bringing more order or more disorder. Now, the units for enthalpy, if you remember, are in kilojoules. The units for entropy are in joules. So I must convert joules to kilojoules for this reaction to work. Okay? So it's the enthalpy minus the temperature in Kelvin times its entropy, because if I take my Kelvin times kilojoules per Kelvin, that cancels out the Kelvin, and then I'll have kilojoules minus kilojoules. And Gibbs free energy will be in kilojoules. If delta G is a negative value, that means that the reaction is spontaneous and that it does take place. If it's a positive value, that means that it is non-spontaneous. So once again, what does H mean? Enthalpy. What is enthalpy? Heat. What does positive mean? Endothermic. Negative? Exothermic. What is S? Entropy. What does it mean? Disorder. What does positive mean? More disorder. Negative? More order. What's G? Gibbs free energy. What does it mean? Spontaneity. Spontaneous or non-spontaneous. What does a positive value mean? Non-spontaneous. Negative value means spontaneous. So the maximum amount of energy that can be accomplished to do work is going to be your delta G, and it's based on the energy transferred as heat minus the energy used to create disorder. There's two methods that we could use to calculate delta G. This is the first one, delta H minus T delta S. How do we get delta H? Well, if you remember, you could use calorimetry, Q equals MCAT. You could use Hess's law, enthalpies are additive, or you could use the back of the book and do products minus reactants. How do we get delta S? We can do products minus reactants. And calculating delta G, we can use this equation here, or we could do products minus reactants. So, first one we're going to do is find delta G using the delta H value and the delta S value, and here's my temperature. So I'm going to do delta G equals delta H minus T times delta S. Don't forget that delta S, I need to convert this joules right here to kilojoules. So delta G equals delta H, which is negative 218. By the way, that means it's exothermic, minus my temperature in Kelvin times 765 in kilojoules would be 0.6765, and don't forget that's negative. Do all that in math and you get delta G equals positive 15.3 kilojoules, and since it's positive, that means it's non-spontaneous, which means the reaction will not take place at this temperature. So the question is, at what temperature does this reaction take place? What temperature does it become spontaneous? Well, if it's positive here, and spontaneous is when delta G is negative, it has to pass through 0. If I'm going from a positive number to a negative number, it has to pass through 0. So what I'm going to do is I'm going to make delta G 0, plug in my delta H, plug in my delta S, and just solve for the temperature at which that takes place. So if I rearrange this equation, T is going to equal delta H divided by delta S. So negative 218 divided by negative 0.765 gives me a temperature of 285. If I subtract the 273, that's going to tell me what temperature this reaction does take place. So if I plug in signs here, like a negative sign, if it's exothermic and the reaction brings more disorder, the reaction is always spontaneous at all temperatures. If the reaction is endothermic and it brings more order, then the reaction is non-spontaneous at all temperatures. If it's exothermic and it brings more order, it's going to be spontaneous at low temperatures, non-spontaneous at high temperatures. It depends on this value right here. If the reaction is endothermic and brings more disorder, then it's spontaneous at high temperatures and non-spontaneous at low temperatures. Basically, you're just plugging in signs right here and doing the math. So that's the first way you can solve for delta G. The second way is the real easy way, the back of the book, products minus the reactants. Delta G of formation is the free energy change that occurs when 1 mole of a compound is made from its elements, once again, in their standard state. So if you're producing it from its elements, that once again means that delta G of formation for an element in its standard state is going to be 0. So for delta H and for delta G, for the formation of an element in its standard state, it's 0, not for delta S. So we're going to do products minus reactants. And if we're doing products minus reactants, remember this right here is going to be 0. So I look in the back of the book for aluminum oxide. Minus this right here is going to be 0. Look in the back of the book for iron oxide. So basically it's just aluminum oxide minus iron oxide. And we get an answer of negative 838 kilojoules per mole. Now, it is negative, which means that this reaction is spontaneous, which means this reaction does take place, which makes sense because you've seen this reaction before. These are the two balls that I slammed together. Does this reaction take place? Yes, you've seen it. If I slam the balls together and nothing happens, then that would mean it would be non-spontaneous, and this would be a positive value. Now, remember, spontaneous does not mean that the reaction is fast. Okay? The rate of a reaction is dependent on chemical kinetics, not thermodynamics. Okay? If I throw a nail out in the backyard, it might take a month for it to rust, but it will spontaneously rust.